Hi everyone! This is my kitchen. I'm going to try to do today an experiment that I'd normally do in a lab using some slightly better equipment. I'm going to see if it works. It might not do. Apologies if it doesn't. So you should probably already know that if you've got something like a wooden spoon and you're using it to cook, even if you put the wooden spoon at the top of a hot pan, the end isn't going to get hot, and that's because it's an insulator. It doesn't transfer energy very easily. If you were to do the same thing though with a spoon, if you start heating this side, eventually the end would get hot and be difficult to hold. And that's because the heat is being transferred along the spoon from where it's heated to the cooler end over here. And the way that that heat moves is by conduction. So we're going to do an experiment of conduction. The equipment I have is a chopstick, which I have covered in tin foil, and I've wrapped it around a few times. I've used the same number of wraps to try and keep it a fair test throughout. I've got the hob, and hopefully I'm going to try and time it as well. I'm not sure. I'm going to try and do something fancy and add a timer to the bottom of the screen, but that may or may not work. Let's see. This might not work at all, so if it doesn't, I'm afraid it doesn't work. Giving it a go. So this is the setup. I have got my chopstick covered in foil, resting on the burner. I'm going to put the burner on the right hand side on, and then I've got these little pins, and I'm going to attach the pins to the metal by using a bit of Vaseline. Now what should happen is that as we heat the right hand side, the energy is going to be transferred from the hot side where the burner is towards the cooler left hand side, and the heat's going to be transferred by conduction along here. Now, as that happens, the pins should start to drop off because the heat will melt the Vaseline as the heat is transferred. So here is the setup. You've got over here, the pins have been attached with Vaseline. I tried to use the same amount of Vaseline for each one. So you've got a pin here, pin here, pin here, pin here, and you probably can't see in the ruler, but those were 5 centimetres apart each. Timing is not going to be perfect, but let's see. If I press start here, the time when we're starting is 4 and a bit seconds. Oh no, not quite. There we go. So we'll have to look back at that there. So I'm heating the end. So when this is happening, the bits that are closest to the flames obviously are getting hotter. Oh, there's the first one's gone down. And as they gain energy because of the heat, the particles start to vibrate more, because the hotter something is, the faster the vibrations. And as they vibrate more, they knock into the next door particles, so that heat starts getting transferred along. And you can see, I'm quite pleased with this. So I say I'm quite pleased with this, but after this point, I had to stop for the experiment, as you'll start seeing a lovely bit of smoke as my chopsticks started to catch fire, which is very exciting. But hopefully you got the idea. You could see that those pins were starting to drop off bit by bit, and you'd hopefully be able to predict that the next pin to fall off was here. So that is conduction. So conduction is transfer of heat through a solid, and we'll look a little bit more at that using diagrams and stuff in a minute. But you've got a couple of quick questions to do. So if you go in your worksheet, you will have to come back to this video. Please look back at the times that these 2 little pins dropped off, and remember you've got to take off, I think it was about 6 seconds to get your time. So look back at the video now, just note down what time the first pin dropped off and the second pin dropped off.